Okay, so now we're going to talk about multiplicity. So multiplicity is your power on your factor. Okay, so essentially it's the power of your factor. Is it to a 1? Is it 2? Is it 3? What is the power on your factor? Okay, your multiplicity, we're calling it K for now, is always going to be greater than or equal to 1. And it's an integer. Okay, it's always going to be an integer. Now, if K is odd, of 3 or higher, so if it's 3 or more, so if K is odd at starting at 3, greater than or equal to 3, if it's an odd that is greater than or equal to 3, I call this a drive-by. Okay, so it's going, and then it's going to speed up and then slows down and then speeds off through the point. That's how it's going to behave around that point. So I'm going, and I'm going to creep on through and then zoom out. Huh? Yeah, this is odd. But it's odd values that are greater than, that are 3 or greater. Okay? When you have 1, so 1 is an odd number, but when you have 1, that's just our regular, yeah, so 3, 5, 7, whatever. 1, when your K equals 1, it just crosses. It's just a regular little crossing. Okay? Again, I call this a drive-by. It just, in my mind, that's what I've been calling it since 10th grade. I can't stop. I don't know why. But hopefully you get it. So it's going. So the difference is when K is 1, we just go straight through, right? We're just a smooth little drive and just coasting along. When it's K is greater than or equal to 3 odd, is going and it's like, ooh, slow down. Ooh, no, let's go. Hence why 15-year-old me said, oh, it's a drive-by. And I can't stop. So here we go. If K is even, whether it's 2, 4, 6, 8, who do we appreciate, whatever it may be, it is going to be tangent to the x-axis. So it's going to be sitting, and I call this a kiss. It kisses the x-axis. Just going to give it a little peck. Okay, essentially what that means is that you are never, your value of your output is staying positive or negative, right? It's going to stay that same value. So notice here, I'm a positive y-axis, and then here is going to bounce back up. It's going to remain a positive y. Does that make sense? Okay. So again, you can stick to, this is a dB, I drive by. This is a little peck. And those are your two different multiplicities. And it all depends on your factors. Okay. So we're going to now apply the terms of multiplicity. We're going to generally only have, you're only going to either be putting 1, 2, or 3 on your factors. Okay. If it's a 1, it's going straight through. If it's a 3, it's a drive-by. If it's a 2, it's a peck. And that's how it's behaving. So let's take a look at this graph. Okay. So when we look here, we're going to first identify the fact, we're going to identify the fact that it says this is a 5th degree polynomial. Okay. Because it's a 5th degree polynomial, that means that all of our multiplicities should add up to 5. Okay. So all of our multiplicities should add up to 5 because it's a 5th degree polynomial. All right. So we're going to identify our x-intercepts, and we're going to talk about their behaviors. So for this function, we have f of x equals, we have a because we're not solving for a right now, so we don't know what a is. But we're going to look at our factors. So our first one is at -2, correct? So -2 as a factor is going to be x plus 2. What is my graph doing at x plus 2? It's second, it's touching it, right? It's giving a little peck. So that means that my power on here is a 2. My multiplicity is 2. Okay. Now we're going to look at our next x-intercept, and that's at 1. The factor would be x minus 1. What is the behavior through 1? It's a drive-by. It slows down and zooms off, right? So therefore, my multiplicity on my factor is going to be a 3. Do you notice how 2 and 3 make 5? So this is why it's a 5th degree polynomial. Okay. That's why when we talked about your extremas, your max and mins, it could be up to, right? But it's not guaranteed to be 5. And that's because once your factors start having multiplicity, it's going to start making your graph do weird things, right? It's going to be like, oh, never mind. You're not going to go back up. You're going to stay down. Okay. It's going to make it do weird things, but that is how it works. That is it for multiplicity. Okay. So it's how is it behaving around the x-axis? If I'm just regular schmegular, that's a 1. If I'm giving her a little peck, that's going to be a 2. If I'm doing a little drive-by, that's going to be a 3. Okay? Let me see. It's just because how the number behaves. It's a cubic function, curvester. Yep. All right. Do we feel like we get multiplicity or we need more examples of multiplicity? We get it? All right. Okay. Let's go back to word problems. So here we have the polynomial function. So beautiful. It is used to find the depth that a ball 10 centimeters in diameter sinks in water. The smallest positive of x of f of x equals the depth of a sphere sinks. Determine the depth that a pine ball with a 10 centimeter diameter sinks in water if d equals 0.5. So we're not going to actually work this problem. I just want to point out to you that this problem looks intimidating, right? But it's not, okay? Pi is just a number, and you're just going to use pi on your calculator. It is literally just a number, okay? Next, you don't have 2 unknowns. You actually only have 1 because they gave you the value of your d. So where d is missing, or d is, you're going to plug in 0.55. Okay? The other thing that it says is that it wants to know what the determine the depth that a pine ball with a 10 centimeter diameter sinks. So if you have a 10 centimeter diameter and you want to figure it out, then you're looking for when it sinks, when it's going to hit the bottom, right? When is it going to be at the bottom, the ground? How long, right? So then that's just a matter of plugging in and then looking to see where you are at 0. Does that make sense? Essentially, most of these problems are just going to be graph and find my 0. Okay? So I want to again point out this is not a hard problem. It is a calculator problem. You are literally just going to type in the calculator what you see and then look for your zeros. Does that make sense? Okay. So when it says that, well, no, not a 0. This is a maximum, a depth. So let's look at it. So again, you are not doing anything extra. You're letting the calculator be your tool. And you're going to use the pi button. So your pi button is right here. So when I start typing this in, I'm just literally typing. I have to use parentheses because I don't have the fancy fraction bar like you guys do on the handhelds. So I have pi divided by 3, x to the third. That is just my leading coefficient. That is all it is. Minus 5 pi x to the second, right? And then plus parentheses 500 times pi times 0.55 because it told me the value of my d divided by 3. Okay, so we're going to hit graph. Now, what's going to happen with this problem is that you're like, it didn't work. I see nothing. What is going on? It's just a line. Okay, that means that you need to adjust your window. If you can't see anything, it's not our friend. So I'm going to go to zoom. I'm going to zoom out. I like to try zoom fit sometimes to see if it'll help me. Just to see what it'll do. See how smart Sylvia will be. Will she show me my image? Will she show me some good stuff? Sometimes she does. Oh, look, she did. Okay. Okay, so we're looking for the smallest positive 0 of f of x equals the depth that the sphere sinks. So I need the smallest possible zero, and that smallest possible zero would be not this one, because this is positive. No, it would be this one, because it's positive. It's at the smallest positive zero. So I'm at second trace, and I'm going to go look for its zero. Clickety click, 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 click. Hit enter. I'm going to go below. Click, 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 click. Crawl, spider, crawl. And he's going to tell me my smallest possible zero. And it is at x equals 5.33333333. Okay. Again, word problems are not the hardest problems on the test. You just have to read them. Okay. It told me here, what am I looking for? It says it, right? I didn't have to think. It says smallest possible zero. Did we find it? Yes. That was, what was it? 5 point. That's good enough, right? Yeah. And that would be the death. Okay. So reading the word problem, you usually aren't going to do a lot of actual calculating from a word problem. It's can you set it up and interpret what you see? Can you set it up and interpret what you see? Okay. All right. Rational zero theorem.